Now we are into the next topic, which is what we call the shear strain. So basically, this is the strain that is caused by the shear load or the shear stress. Okay, so ano man yung shear strain? So ang shear strain, this is the tangent of the total change in angle occurring between two originally perpendicular lines in a body during the formation. So basically, if kuntahay natay material or natay object, 'di ba? If atuan siyang birahon in this direction padulong sa right, what do you think will happen to our object? 'Di ba in this area makita nato na mura siya ni-sway. So i-3D nako ni ha. Forgive me sa ko ang drawing. Kay wala pa jud ko'y digipen. Okay, so if birahon na to ning block nya kanina area atong i-consider, 'di ba mura siya og na-sway? Na-sway, mura siya na-sway. Okay, so kani siya, this is the shear strain. So ang imuhang object, if dili siya dali ma-sway, so grabe siguro ang iyahang modulus of rigidity. So kanang modulus of rigidity, istoryahan lang nato na later. Okay, so nganong kanina area ang gi-consider sa sa toang figure? So kanina area because this is the parallel area with regards to the force being applied. So if puntahay block ni siya, type block, kung kanina kung kanina area nga to ang i-consider, that is normal, 'di ba? Shear man, so ang ato ang i-consider na area is kani. So bantayan nato na dili siya masway. So if inana siya daan, dapat dili siya himong parallelogram. Nang dili siya mabira sa load diri. 'Di ba pag birahon siya mo ingon ani man mo sway siya. So dapat dili siya mabira because if masway siya then naa na siya shearing or naa na siya shear strain na nahitabo. Okay, so how do we or where is shear strain in the figure? So ang shear strain is kani. Kung mao ni ang original, if this is the original figure, ang shear strain is kani kani ug kani. Kasi ito man yung angle of deviation niya. Kibali from vertical na orientation na inclined siya. So ang kanang angle of inclination, that is what we call our shear strain. And not just that, but also here. Kasi 'di ba, from horizontal ni ano siya, ni deform siya. So kaning deviation diri na angle, this is also shear strain. Okay, so i-add mo ng duha ka angle, then that is your total shear strain. Okay, dili ning angle sa tong ang shear strain. Ang shear strain is the deviation from your reference axis. So since this is your reference axis, kay mao ni ang straight line, so ang katong angle or movement niya that is considered the shear strain also here. Okay, so nakita ninyo sa formula, ang shear strain, ang iyang symbol is ito. 'Di ba sa normal, ang symbol niya is epsilon. Sa shear strain, ang symbol niya kay ito, gamma. So si gamma is actually pi over 2 minus the theta nasa tunga. So, di ba ang pi over 2 kay radians man na sa 90 degrees na angle? So, minus kaning naa sa tunga na angle, then ang makuha nimo is kanang combination sa kilid. So, kanang combination sa kilid na angle, that is our total shear strain. Okay, so, kung sa normal, naatay relationship na elasticity equal to stress, normal stress, over shear over normal strain. naa pod kay inana sa shear. So, ang counterpart ni elasticity sa shear, we call that modulus of rigidity. So, modulus of rigidity, G, is equal to the shear stress, this is shear stress, over shear strain. So, ang pasabot aning modulus of rigidity, this is the measure on how tough your body is with respect to shearing or sa strain. So, for example, dako kag G. So, pasabot, dili ka dali mo ingon ani mo deform. Maski pabira-birahon ka dira, dili ka masway like this. Intact gihapon ka. Okay? So, if masway ka, then possible, gamay lang ka og G. So, unsa man ang mga objects na gamay lang og G. For example, rubber. Di ba ang rubber, imo lang na siyang kaliton og bira, ma-deform dayon na siya. So, hina siya og resistance sa shearing strain. Hina siya resistance sa shearing strain. Okay? But if kanang mga kuan, mga steel, so maski birahon nimo siya, dili kay nimo makita ang iyang pagka-deform. Bali intact gihapon ang iyahang surface. Okay. And then, how do we relate modulus of rigidity to modulus of elasticity? So, inana lang na ilang relationship. Modulus of rigidity is equal to elasticity over 2 times 1 plus Poisson's ratio. Okay? So, kana lang atong timan-an. And then, here's the technique para masayon isolve. Okay, so given ingon ani mong figure, ang total shear strain is i-add nimo tong deviation, di ba? Anak ko, ang deviation sa angle. So this is gamma 1 and this is also gamma 2. Now, as for the sign, pagpasulod gani ang imong angle, pareani, mao man ni ang reference point kaning straight. Pasensya na jud kay mo ha, wala jud ko'y pen. Dali lang. So if mao ni imong reference point, kung mao ni itong reference na point, di ba ang deviation is pasulod. So if pasulod ka, this is negative. So kung gamma 1 ni, so gamma total is equal to gamma, negative gamma 1, negative gamma 1 kasi nga kaning si gamma 1 pasulod siya. And then kaning gikan sa vertical padulong sa deformed pasulod pod. So that is also negative. Negative gamma 2. Okay, so murag gi-combine ng gihapon nimo siya but the sign is negative para sa tanan. Okay? What if pagawas? Kung tayo mo ni ang original na area human, pagawas ka. Paingon ana. Okay, so mo ni ang original and then igawas ka. So this is gamma 1. Mo ni ang original, nigawas ka. This is gamma 2. So ang total na shear strain is positive gamma 1 plus positive pod na gamma 2. Okay, so depende na sa imong deform kung asa siya padulong. Alright, so let's have an example. Okay. So, an initially rectangular element of material is deformed as shown in the figure. Note that the deformation is greatly exaggerated. So calculate normal strains, epsilon x and epsilon y, and the shear strain gamma for the element. So as you can see, ang undeformed state is ito. Itong rectangle. So, naagi-apply na load. So, ang nahitabo na sa iya is nahimo na siyang parallelogram na rhombus. Okay, so first pangutana is what is the normal strains? So, maski shear strain atong topic, but ma-apply man gihapon nato diri ang definition sa normal strain. So, naapil siya sa problem. Okay, so calculate normal strains, epsilon x and epsilon y. Ayaw lang kalimtig yun ang definition sa normal strain. So, ang definition sa normal strain is always change in length over original length. 'Di ba? Change over original. So, if si x atong isolve, look at the axis for x. So, kani ang axis for x. So, kani sad ang axis for x. So, ang change ani is along pud sa axis sa x. So, dili kani nga value, dili pud kani na value kasi sa y man na. Dili ta magtanaw sa x. Sa x, change man, so along the length of x. So, what is the change along the length of x? The change is 0.7 times 10 raised to the negative 4 inch. Okay? Over the original is 0.25 inch. Okay? So, kanina, dimension ang kwaon. Kanina, change. Kasi nga, normal strain ang atong ginapangita. So, the answer is 2.8 times 10 raised to the negative 4. How about sa y? Sa y naman, since ang define sa axis na y is vertical, so sa vertical ta magtanaw. So, ang change ana sa vertical, unsa man na dimension, kanang 1.2 times 10 raised to the negative 4. Nga naman, because that dimension is along the y length or the y-axis. Okay, so dapat siya atong change. 1.2 times 10 to the negative 4. Nakuha ninyo? Over original length sa material, ang original length sa material, 0.2. So therefore, we can solve the shear in strain equal to 6 times 10 raised to the negative 4. Okay, so mauna for normal strain sa. How about for the shear strain? For the shear strain, as I've said earlier, di ba angle ang shear strain? So, dapat opposite over adjacent. Kibali, kung tayo kani, ang ato ang undeformed rectangle and then na-deform siya looking like this. So, ang shear strain, na part is kani nga deviation, we call this 2 sigma, gamma 2. And then, kani, pagawas pod, ang deviation niya from the vertical, we call that gamma 1. Bala na mo, sa yung tawag. Basta, deviation siya from the vertical. Kani po, deviation from the horizontal. So, kibali, ang gamma 1 o gamma 2, both sila pagawa sa rectangular element. Mamani ang rectangular element. So, ang duha is pagawa. So, ang mahitabo, ma-add sila. Okay, unsa ang value? So, ang gamma 1 is opposite over adjacent. Ito, 'di ba? Ito, opposite ito, 1.5 over adjacent, 0.2. And ang gamma 2 naman, opposite over adjacent. So, for this angle, ang iyahang opposite na dimension is kani 1.8 times 10 raised to the negative 4 over 0.25. So, both sila plus kasi pagawa sila sa element. So, therefore, ang shearing strain is 1.47 times 10 raised to the negative 3. Okay? Okay. Alright. Thank you so much. Do you have any question? Guys? Hello?
Wala, ma'am. Wala, ma'am.
Okay. Ang technique ha para makasolve mo og shearing strain. Okay, so next example. An initially rectangular element of a material is deformed into the shape shown in the figure. So find again the normal strains x and y and the shear strain gamma for the element. So ito yun. Okay? So ang undeformed state na to is rectangular, straight gid na siya. And then, with the application test, so na-deform siya. So, mao na ni ang nahitabo niya. So, for the for the normal strain in X, tong epsilon X, and for epsilon Y, dili gyapon nato kalimtan ang iyang basic definition maski unsa pa na nga axis. Normal strain is always change in length over original length. Okay, so for x, ang x-axis man nato ito, di ba? So ang change niya from 0.2 naging 0.192. So change is always final minus initial. So ang final length niya is kaning 0.1992 minus original length niya which is 0.2 divided by the original length 0.2. Okay? How about ang sa y? Sa y naman, ang original niya nga dimension is ito. Original dimension is 0.15. And the final dimension becomes 0.1515. So, final minus initial, 0.1515 minus initial na 0.15 over original length that is also equal to 0.15. So, therefore, the strain in y is equal to 0.01. Okay, so as you can see, si strain in x is negative. So that means that there is an opposite effect sa x-axis. So mura siya ni-shrink sa x-axis. Unlike sa y nga ni elongate ang dimension. Okay. Next question is katong total shear strain. So as you can see, in this reference na axis, ang ato ang deformed is paingon ani na. So from the reference axis to the deformed, naatay angle. And then, from the vertical axis to the deformed, naasad tay angle. So ato lang timan-an kinsa dira ang ma-minus, kinsa ang ma-plus. Okay, so kaning 15.7 minus yun ni. Kay pasulod man siya from the reference point or reference axis na ingon ani, nisulod ang imong deviation so morning minus. And then, kaning 16.6 pagawas man siya sa imuhang element. So therefore, positive. So naitabo na noon ang total shear strain is the difference lang between the tan of the two angles, which is equal to 0.157 radians. Unitless gyapon ng shear strain ha, wala siya unit. Mura po na siya normal strain. Okay, so do you have any question with our topic right now? None? Okay, so let's go to our next topic. So, kani ang pinaka-challenging sa tanan topic. So, first na to na, first exam coverage. Kaning statically indeterminate beams. So, unsa din ang statically indeterminate beams? Okay, so, di ba, sa to ang mga structures before, para ma-solve na to ang mga forces, we always use the equilibrium equations. So what are those equilibrium equations? Natong ginabalik-balik. Summation, forces, y equal to 0. Also, summation forces x Okay, summation forces X equal to 0. And then, summation moment is equal to 0. Mani ang tulo ka equilibrium equations na atong ginabalik-balik to compute the forces. So, if makaya ra sa tulo ka equilibrium equation ang pag-solve sa forces sa usa ka structure, then your structure is what we call statically determinate structure. Okay? Kasi makaya lang sa 3 equilibrium equation ang unknown sa imuhang structure. But, if dili makaya sa 3 equilibrium equation ang mga unknown sa imong structure, then your structure is now become an statically indeterminate structure. So, maging indeterminate yung structure mo pag wala kang maski isa na ma-solve, maski maubos mo pa yung tatlo na equation. Okay? So, ang number of forces unknown exceeds the number of equilibrium equation. Okay? So, unsaan man nato para ma-solve? So, gamitan nato og role sa deformation. Kasi ang deformation, makatabang na siya to simplify the structure. Okay? And to find the unknown forces in your structure. So, basically, here are the steps in solving indeterminate beams. So, what are those steps? So, first things first, we have to draw free body diagram and derive the equations of equilibrium. So, pinaka-first gid na nga buhaton, putlo nimo tanan member and then pangitaon nimo unsa ang mga present na force. Okay? And from that, you have to derive the equations of equilibrium. So, maski wala kay ma-solve na isa sa ilang, at least, ma-express nimo ang isa ka member in terms sa isa ka member. So, mga ang goal dera. And number 2, derive the compatibility equations. So, you have to allow the deformation to take place so that you can actually get a relationship between quantities. So, saan nimo pag-relate ang mga quantities? So, gikan na siya sa deformation na drawing. Katugong gi-drawing na to last time, di ba? Nakabalo mo na ang deformation is just blah, 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 blah. So, magamit na to na skill diri na topic. And then, number 3, you use Hooke's law to express the deformation in terms of forces. Kibali sa number 3, since di ba ang deformation is just pilae lang man, force times length times area over elasticity. So, masolve na to siya. And then number 4, pag nanakay number of equations, imuha na dayon ang i-algebraic solution to find one of the unknown forces. Okay, so to get my point, let's have an example. Alright, so the figure shows a rigid bar that is supported by a pin and two rods, one made of steel and the other is bronze. Neglecting the weight of the bar, compute the stress in each rod caused by the 50 kilonewton load using the following data. So, ito yung structure natin or system natin, guys. So, kibali, kaning nga bar, it is being held by steel and bronze. And then, pilit siya ginababa ni 50 kilonewton na load. There is a free end. So, therefore, naapod tay mga areas and elasticity na sa material. Okay? So, first things first, we have to draw the free body diagram. So, the free body diagram looks like this. So, sabi ko, putlo na to tanan mga members and then tanawon na to kinsa ang nigawas na force. So, if putlo ni, so mao ni mo gawas sa mga forces. Okay, and don't forget, there is also a downward force, 50 kilonewton at the free end. Okay, so what do? We will sum up moment there is a hinge. So, of course, naapoy forces sa hinge, wala lang napita, na siya vertical o horizontal. So, if mag-sum up tag moment sa hinge, so, unsa na ang makita sa tong equation? So, summation moment A is equal to 0, where clockwise is positive. So, that is equal to, okay, so, PST, ang PST no, ano din siya, counterclockwise. So, sige lang, PST times 0.6 plus pre-bronze times 1.6 is equal to this 50 times the total niya nga moment arm about A, 50 times 24. Okay, so therefore, we can have this following equation. So, don't worry guys, masika na alay mo ma-solve kasi later on, makita naman po tagpaagi na makuha nato maski isa lang ka force dira. So, asa na to siya makuha? Well, we must allow the deformation to take place to derive the compatibility equation. Remember guys, ang ato ang bar pa siya. But with the presence of the 50 kilonewton load, wala siya choice kung dili mabira siya. Okay? So if mabira siya, mag-elongate pud ni nga member. We call this elongation sa steel. Okay? And then ito din, we call this elongation sa bronze. Okay? So, balikan nato diri sa tong first na figure. 'Di ba? Mao ni ang bar human na ay nibira diri na side. So, unsa may expectation nato aning bar? Syempre mo swing na siya downward. Kay ni swing siya downward, wala ni choice ang steel o si bronze mag-extend gyud na sila. That's why ito yung nangyari sa ating figure. Okay? And now guys, the goal is manimog triangle na pwede ninyo ma-relate ang relationship sa mga quantities. So this itself is the triangle, 'di ba? So we can have the deformation or elongation of steel over 0.6 is also equal to the deformation of bronze over 1.6. So therefore guys, mao ni ang ilang relationship. The deformation of steel is just equal to 0.375 the deformation of bronze. So mao ni ang atuang compatibility equation. Okay? But take note guys that deformation is also equal to force times length over area times elasticity. So, having known that, we can actually substitute all the known values, 'di ba? Kasi nga, this is elongation sa steel is equal to 0.375 elongation sa bronze. Okay? So, substitute lang. Substitute. And then, we can have this relationship. The force in steel is equal to 3.614 sa bronze. Okay? So, asa man ni gikan? Gikan na pud ni sa pag-substitute nato sa mga quantities. Okay? So, mao ni ang was. Nganong kailangan nato kwaon ang force? It's because the question, the problem, asks for the what? Asks for the stress in each rod. So, if stress in each rod, di ba force over area, so wala tayong mabuhat, kuhaan gid nato ang force sa steel ug sa bronze. Okay? So, wala na tayong problema. Naatoan ng na-express na ang force sa steel in terms of bronze. So, ang force sa steel is just equal to 3.614 sa bronze. Okay. But guys, don't forget, naabi at equation 1 no, wherein Ito, ato ganing kani, ito, di ba? Equation 1, steel and bronze siya. So, sa equation 2, ang involved sad is steel and bronze. So, substituting equation 2 to equation 1, so this is what happens. Okay, na-substitute, nakita ninyo. Alright? And then, pag-substitute, ang ano na lang is the bronze. 4 sa bronze. So, madali-dali na nato nag-solve ang 4 sa bronze. Ang 4 sa bronze kay 31.844 kilonewton. Okay? And how about the force sa steel? So, ang force sa steel is just 3.614 force sa bronze. Asa man nagikan? This is actually equation 2. So, therefore, makuha na nato ang force sa steel now equal to 115.084 kilonewton. Okay? But, wala pa tanahuman kasi lagi ang gipangita is the stress in each rod. So, kay stress man, force over area. So, ang force sa steel na na-compute nimo divided by given sa area sa steel. Okay? And how about the bronze? Sa bronze din, given, compute naman nimo ang force sa bronze divided by area na given sa bronze, then makasolve na pud ta og iyahang own na stress. Okay? Okay, so do you have any question? Now, do you have any? Okay, so let's have another example. So the three, yes, na question? Nalagi nag-open nag-mic. Sige lang, tubag lang mo guys, okay raman. Wala? Okay, so let's proceed. The three steel rods, each of cross-sectional area 250 square millimeters, jointly support the 7.5 kilonewton load. Assuming that there was no slack or stress in the rods before the load was applied, find the force in each rod. Use elasticity sa steel equal to 200 gigapascal. Okay, so ito yung figure, guys. Alright? So, of course, unsay ma-imagine nato sa figure? So, si figure na ay tulo na ka rods. And then, it carries kanang 7.5 kilonewton na load. Okay, so, first things first, we have to draw the free body diagram. Alright, nakita ninyo ang free body diagram. So, how to solve? Summation forces horizontal equal to 0. So, isa man ang mga horizontal forces dara. PAD sine 25 minus or equal to, gibalhin na, equal to force AB sine also 25. So, makancel ang sine of 25. What's left is force AD equal to force AB. So, pareha ra dining force AD o force AB. Now, the question is, how about PAC? So, mag-summation forces vertical ta when positive forces are upward forces. Okay, so sa vertical, PAD cosine of 25 plus PAB cosine of 25 plus PAC equal to 7.5. Since naman na-establish na nato that force in AB is also equal to force in AB, then substituting, diba? So, mao na ni ang atong equation 1 in which unknown si AB at si AC. Alright? So, this is indeterminate kasi maski nag-apply na kag equation, wala gihapon kay makuha maski isa. Very good. Next, allow the deformation to take place to derive the compatibility equation. So, in this part, guys, dapat paganahon yun na to tong imagination, no? So, if ginabira siya 7.5, ito yung mangyari sa ang ating figure. Kita nyo? Ito yung original na member. And then, gibira sa 7.5. So, nabira pod ang mga member. And then, we also have to draw the deformation of each member. So, kanina member AB, nag-elongate daw siya. We call that elongation the delta or deformation AB. Si AB po, napod siya yung own deformation. We call that AD, deformation AD. Si AC, rod mo po ng AC, so napod siya yung own deformation. Para lang yun, makiking 7.5. So, mauni ang dagway sa to ang triangle, guys. Okay, mauni ang game changer. Mauni ang susi para ma-solve. So, ang gibuhat lang ani is kanina member, gi-extend lang siya. We call that deformation at AB. Ito din, gi-extend siya kasi nga tension. We call that AD, deformation sa AD. And then, kanina member, gi-elongate po siya. We call that elongation AC. Okay, how about the angle, guys? Dapat makita po na to ang angle. So, if 25 degrees ang ilang inclination with respect to the horizontal, 'di ba? So, unsa man atong maingon? If this is 25, this is 65. Tama? 65 ni. So, this is also okay. Again. Kung tahay, ang kanina angle, 25 degrees. 'Di ba? Pag vertical ang duha ka angles, opposite, they are the same. Vertical angles are the same pag opposite. Okay, so if 25 ni, 25 pud ni. Kung 25 ni, 25 pud ni. Because vertical angles are the same. Opposite vertical angles are the same. Okay, so what's next is atoan ng ikuan. By symmetry, we can just say that the deformation in AB is just equal to the deformation at AB. And then, by deformation triangle, asa man ang deformation triangle, guys? Pili lang ka, maski asa sa duha. Pwede sad ning sa pikas. Basta right triangle lang. Okay, so if ang atong pilion is kani na triangle, kita ninyo, ito yun na triangle. So this is AB. And then ang hypotenuse is AC. And then the angle is cos 25. Kasi nga 25 degrees ito. So we can say that cos 25 is also equal to deformation B over deformation AC. Okay, so mo na ang compatibility equation. So further simplifying, cross-multiply lang ang duha. Oh. Therefore, we can say that the deformation AB is also equal to the deformation AD is equal to deformation AC times cos 25. So, mao ni ilahang compatibility equation or how the quantities relate to each other. Okay, so asa ni gikan? Base lang pud na sa to ang sketch sa deformation. Okay? Alright, so therefore, by using Hooke's law, that kaning deformation equal to PL over AE. So, therefore, if delta AB is equal to delta AC cos 25, diba? And then delta AB is also equal to the force AB times length AB over area AB times elasticity AB is equal to force AC times length niya, PL over AI nga, length over area. So, area times elasticity. And then, ayaw kalimot ang tanan-tanan times san o cosine 25. So, therefore, pag simplify nimo sa tanan-tanan number na imo makita, so mao nimo gawas. Force AB that is also equal to force AD is equal to 0.8214 force AC. So, kibali, gigamit lang nimo si compatibility equation para makuha nimo ang relationship between the unknown forces. Okay? So, since naa naman ka atong equation 1 nimo, ito 'di ba yung equation 1? Sorry, this is D pala. D ni D. Okay, and then, wait, na-substitute na. So, ang gibuhat is gi-substitute na ang equation 2 is to equation 1. Pareha ni. Ang equation 2, gipaslak na dere sa equation 1. Ang equation 1 is kani. Kani, mo na equation 1. So, na-express naman nato si force AB in terms of force AC. So, mapaslak na to dito. We can now actually solve the force AC. Okay? And then, ang force AC naman, magamit na to siya para ma-solve pud ang force AB as well as force AD kasi nga pareho lang. So, actually, the forces are 3.013 for AC and 2.47 for AB and AD. Okay? So, if wala kay thinking about sa deformation, dili gud nimo ni ma-solve ni na truss kasi nga very indeterminate. So, dito ana ka nidula sa iyahang deformation para makakita na pud kag isa ka equation na imuhang magamit. Kasi 'di ba sabi nila sa algebra, if you have two unknowns, you also have to have two equations para ma-solve. If you have three unknowns, you also have to have three equations para ma-solve. Okay, in this case, how many equations lang ang atong na-formulate? Dili man ta maka-summation moment ani. Ang na-formulate lang nato is duha lang, summation forces x and summation forces y. Okay, but tulo ang unknown. Ang unknown is AB, AC, and AD. Asa nato gipangita ang ikatulo para ma-solve nato ang system? Nangita tag ikatulo na equation from the relationship of its deformation. Kaya mo na ginatawag nato na deformation triangle. Okay, so all lang to guys for today. Okay, so if you do have questions, kindly open your mic. Hello?
Wala
Wala?
naman, ma'am.
Sure,
Apo.
yes, Mr. Ahmad. Miss or Mr.?
Stir, ma'am.
Mr. Sorry. Yes
Ma'am,
po.
sa pagkabalo pag statically indeterminate ang isa ka problem.
Saan pagkabalo kung statically indeterminate?
Opo.
Indeterminate? Okay.
Opo.
Ingunani gang. Ang buhaton is pag-drawing og FBD sa imuhang system, iha pa pila ka forces ang present. Okay? Ihapon nimo pila ka forces ang present. For example, ang present is tulo. Tulo ka unknown forces. Pero ang mabuhat lang nimo na equation na ma-apply nimo na equilibrium is duha. So dili na pareha ang unknown sa number of equilibrium equation. So therefore indeterminate ang imong structure. Kung pareha ang number of unknowns sa number of equilibrium equation na imong ma-formulate, then may mo na siya og what? Determinate. Example sa determinate. Okay, balik na to ang lesson 4 sa MEC 224. Okay, na may determinate diri na example. Okay. Makita ba ang ano? Ulitin ko ang pag-share. Alright, gang. Tanawan ni na figure. Oh, wait lang, wait. So, ito na figure, gang. Di ba pag draw na to sa FBD, pila ka forces man ang present? 1, 2, 3, 4. Okay, so, pag apply na to sa summation, moment, maski mag-moment rata, naatay na solve na force. Okay, so meaning, this is determinate kasi with the application of your equilibrium equation, na-solve dayon nimo ang force. Kung indeterminate pa ni, wala jud kay ma-solve maski isa. Unsay meaning sa indeterminate? For example, ang kanang wire gidungagan pag isa ka wire. So wala na kay ma-solve kay maana may force na ingon ani. 'Di ba? Maski mag-moment ka sa B, wala kay makuha maski isa. So if sa equation pa lang gani wala na kay ma-solve, then that is already indeterminate. Okay, and then napabata ang diri. O pareha ani. How do we know that this is determinate or indeterminate? Drawing og free body diagram. Okay, and then mao ni na forces ang present sa imong figure. Kung mag-apply ba kog equilibrium equation na ako'y ma-solve? Okay, so na ako'y ma-solve. Na-solve na ko ang aluminum og steel, nag-sum up ra kog moment. Okay? Dili unknown ang force sa aluminum ug force sa steel. Kasi maski nag-sum up ra kog moment, na-solve na ko sila. Kung indeterminate pa ni, wala ko'y ma-solve masadara. Unsay example na ma-determinate ni? What if na ay isa pag yun ay diri na rod? Tapos bronze ang material. So this becomes indeterminate now with the application of this one. Okay? Nagets ni mo, gang? Gang, hello? Okay, so ang buhaton ha, mag-draw og free body diagram, pag-solve og one of the forces. Kung makasolve ka og maski isa, then that is already determinate. Kung wala kay ma-solve, then that is indeterminate. Ngano man? Nganong indeterminate? Kasi nanginahanglan pa ka og lain pa na equation para ma-solve pa nimo imong problem. And that equation is not in the equilibrium equation. Naa siya sa relationship sa mga deformation. Okay.